Hi everyone. So next we'll see the transfer function definition and a few problems. So what is transfer function means? It is defined as the S-domain ratio of Laplace transform of output or response to the Laplace transform of input or source with all initial conditions are 0. It is defined as Laplace transform of output to the Laplace transform of input. Ratio of Laplace transform of output is nothing but if y of t is the output, it becomes y of s by Laplace transform of input is nothing but x of t is the input means it becomes x of s and it is denoted with the h of s. If a circuit has a multiple independent sources, we can find the transfer function for each source and use the superposition to find out the response to all the sources. If you have multiple sources, one source at a time, like a superposition theorem, and we'll find out the Laplace transform. How to find, if you know the transfer function, you can find out the output also. That is y of s is equal to h of s into x of s. If you apply the inverse Laplace transform, you will get the y of t also. So let us see, if you see that transfer function, generally transfer function is represented with the zeros and poles ratio. I'm assuming that k is some constant, k into zeros are s plus z1, s plus z2 and so on, s plus zn by s power n into s plus p1, s plus p2 and so on, s plus pn. This z minus z1, z2, z3 are called the zeros and denominator coefficients are called the poles. These are the denominator roots of the denominator polynomial is called the poles. Roots of the numerator polynomial is called zeros. Here s power n represent that s power n is nothing but type of the system. So n will represent the type of the system and order means highest power of the polynomial will represent the order of the system of the denominator. Let us take one simple circuit like if voltage source is connected in series with the RLC circuit, that RLC or in S domain I have represented here in S domain, and here inductor and capacitor do not carry any initial current and voltage. So VG voltage or inductor is represented with SL, capacitor is 1 by SC. Now if you want to find out the transfer function, here transfer function I am assuming the response is nothing but current response, source is nothing but voltage source. So what is the transfer function? Transfer function is nothing but response by source, I of s by V of s or Vg, I by Vg or I of s by V of s. To find out that I of s by V of s or I by G, apply KVL to this loop. So Vg is equal to R into I plus SL into I plus I by SC or 1 by SC into I. I'll take it common and I is equal to I of R plus SL plus 1 by SC. I need I by Vg, right? So if I cross multiply or if I take this Vg on the other side and this bracket term on the other side, I by Vg, which is nothing but transfer function, is equal to 1 by R plus SL plus 1 by SC. If I simplify further, I'll get SC by S square plus LC plus SRC plus 1. If the voltage across the capacitor is defined as the output signal, so this is your transfer function in S domain. The denominator coefficients will give the poles, numerator coefficient of S will give the zeros. Okay, and if you see here, as I have assumed current as a response, current by voltage transfer function I got like this. If I consider the voltage across capacitance as my response, I'll get another transfer function, V by Vg, right? So what is V means? I into 1 by SC is the voltage across capacitance is divided by what is Vg? Vg is equal to I into I of R plus SL plus 1 by SC. I'll get different transfer function now. That means each circuit will have different transfer functions depends on the response what you have assumed. Initially, if I assume the current as a response, I got one type of transfer function, I by Vg. If I assume capacitance voltage as my response for the same Vg voltage, V by Vg is my transfer function. Likewise, we can have multiple transfer functions for the same circuit diagram. Let us see with the problems. A 500 ohms resistor, 16 millihenry inductor and 25 microfarad capacitor are connected in parallel. Express the admittance of this parallel combination of elements as a rational function of S. You try to get that admittance function, right? Circuit represented in S domain of the above problem. So I'm assuming all these parameters I've given in time domain that I'm converting into the S domain. Parallelly connected, right? So 1 R, SL, C can be represented 1 by CS by assuming all initial conditions are 0. So what is admittance? Admittance is equal to 1 by R plus 1 by L plus 1 by C. So that is equal to 1 by R plus 1 by L is nothing but LS. 1 by SC will become SC. If you substitute those values, numeral values what they have given in the problem statement, and simplify it, you'll get the y of s as 25 into 10 power minus 9 by s of s square plus 80,000 into s plus 25 into 10 power 8. It is a simple problem. So the next problem, if you see, the switch in the circuit shown has a position A. Let's take this is your position A for a long time. At t is equal to 0, the switch is thrown to the position B. This is your position B. Like this, earlier switch was there. Now it is moved to the position B. Like this. Find the current I as a rational function of S. Find the time domain expression for the current I. For this circuit diagram, already we have done the similar kind of circuit diagram during the DC transient analysis. But in the application of Laplace transform, we are doing it in the S domain, and we are trying to convert that into the time domain by applying the inverse Laplace transform. So when the switch is at position A for the longer time, the 100 volts is charged into this capacitance 0.2 microfarad and 0.8 microfarad. V1 plus V2 is charged to the 100 volts. As it is longer time, the entire voltage will be charged into the capacitance, both the capacitance. Now you convert this circuit into the S domain when the switch is moving from position A to position B. So if you see here, the same circuit, if switch is moving from position A to position B, you have two capacitance in series with the 5 kilo ohms, right? The capacitance representation, series representation is nothing but capacitance can be 1 by C1s, first capacitance 1 by C1s, and in series with that capacitance you will have one independent voltage source of initial voltage V1 by S, because initially the capacitance is charged with V1, here V2, because of the longer time the switch is connected with the position A. So the second representation is 1 by C2S is the capacitance, and in series with the independent voltage source V2 by S, and 5 kilo ohm as it is. When you apply KVL to this loop, V1 by S plus minus 2 plus minus 2 plus V1 by S plus V2 by S is equal to 1 by C1S plus 1 by C2S plus 5 of I. If you simplify this, you'll get the current as I is equal to 0.02 by S plus 1250. So we got the current response. What they've asked, current response only. And the current response in S domain, you got it. If you apply the inverse Laplace transform, we'll get the time domain expression for the current I. It's like K by S plus A. K as it is, 1 by S plus A is nothing but e power minus at. A is nothing but 1250. You got the current response like this in amperes in time domain. And the next problem is, if you see here, the transform the circuit shown in the figure to the S domain and determine the Laplace transform. We need to find out the equivalent impedance. This is 3 ohms, 1 Henry, 1 by 4 Farad, right? You convert this into the S domain circuit. 3 ohms as it is 3 ohms. L will become Ls, C will become 1 by Cs. 1 by 4 means it will become 4 by S. These two are connected in parallel, that is in series with the 3 ohms. 3 plus S is parallel with 4 by S. If you simplify this, you'll get the equivalent impedance as Z is equal to 3S square plus 4S plus 12 by S square plus 4. Okay. And the another problem, if you see, determine the current I if the circuit is driven by a voltage source as shown in the figure. The initial value of the voltage across the capacitor and initial current through the inductor both are 0. A resistor, inductor, capacitor is connected in series. Initial current and initial voltage of inductor and capacitor respectively 0. And the source voltage is 40 into e power minus 40. What is the first step as part of this? First, you convert the time domain circuit into the S domain circuit. The transformed circuit as shown in the figure is 40. You have to apply the Laplace transform to this. 40 into e power minus 40. 40 by e power minus 8 is nothing but 1 by S plus A. 40 into 1 by S plus A is nothing but 4. S plus 4. Resistance as it is 3 ohms. L will become Ls, that is 1S. Capacitance 1 by 2 Farad will become 1 by Cs, right? 1 by 2 means it will become 2 by S. And up, what is the next step? You have converted the time domain circuit to the S domain circuit. Then the next step is apply KVL to this loop or find out the equivalent impedance. What is the equivalent impedance? All three are connected in series, right? When all three are connected in series, you can add all of them. 3 plus S plus 2 by S. 3 plus S plus 2 by S. You'll get the equivalent impedance. Then you can get the current I is equal V by Z. Or you can apply KVL and find out the current. That is also fine. So I is equal V by Z. What is V? 40 by S plus 4 by Z. Already got it. If we simplify, you'll get it as 40S by S plus 4 of S square plus 3S plus 2. As you don't have the direct inverse Laplace transform to this term, you need to split that into the multiple terms. By taking the partial fractions, I'll assume this S square plus 3S plus 2 can be written as AS plus 1 into S plus 2. If you multiply these two, S square plus 2S plus 1S, 3S, 2 into 1, 2. I'll split that into 3 terms. One is K1 by S plus 1, K2 by S plus 2, K3 by S plus 4. On the left side, you have 40S by this entire term. Both, if you cross multiply, both the denominator will get cancelled. On the left side, you have 40S. Right side, you have, after cross multiplying this, K1 of S plus 2 into S plus 4, K2 of S plus 1 into S plus 4, K3 of S plus 1 into S plus 2. To find out the coefficients K1, K2, K3, in the left side 40S is equal to, in the equation 40S is equal to K1 of S plus 2 into S plus 4 plus K2 of S plus 1 into S plus 4 plus K3 of S plus 1 into S plus 2, right? In this equation, you substitute S is equal to minus 1. If you substitute S is equal to minus 1, the second and third term will become 0. And this will become 40 into minus 1 is equal to K1 into minus 1 plus 2 minus 1 plus 4. It will become minus 40 by 3. K1 is equal to minus 40 by 3. In a similar way, if you substitute S is equal to minus 2, the first term and last term will become 0. You can get the K2 value as 40. And if you substitute S is equal to minus 4, the first term and second term will become 0. And K3, you'll get it as minus 80 by 3. Substitute all K1, K2, K3 values in this equation. You'll get this equation. Now you can apply the inverse Laplace transform. When you apply the inverse Laplace transform, all the individual terms are like 1 by S plus A form. It will become e power minus 80. Here A is nothing but 1. e power minus 2t, e power minus 4t. The coefficients are kept as it is. So this is all about the problem and transfer function. Thank you all.